All right, hi guys. We're going to talk a little bit about circuits and how to draw them. And this is going to be right before your last test. So let's go to this color pen and let's talk about how to read a schematic. Basically, a schematic is a drawing with a whole bunch of codes on it to indicate what we have. So anytime you see a line like this, it could be at a right angle, or it could be something like this. These are all wires. Now, this is on a piece of paper. It could be totally different in real life. It can go up a wall, around the ceiling, but this is just how we draw a simple schematic, saying, hey, that somewhere on this wire is some other things. Now, if you see on the drawing, we see something like this. This indicates a resistor. And that means it blocks current. It resists current flowing. And it produces heat. And another way to say it is the load of the circuit. Because circuits are basically a whole bunch of elements that does work. Either producing heat or it does something else. And so we usually show you something like that. Now, if we have this resistor in a circle, that's a light bulb. And sometimes we also see it as two circles inside of each other. And if you see any of these, we're talking about a light bulb, and hey, we have light. Now, a circle with two lines, one longer than the other, like a plug, like a socket. This is a plug. And sometimes you see it something like this as well. Now, the reason I'm going through this is that if we start back with labs again, you guys are going to do a whole bunch of these circuits. But we just now, for this year, we're just going to read it. And see two lines, one longer than the other. This is positive, this is negative, this is a battery. And sometimes you see it like that, indicating that we got more than one cell. These are so this is all chemical batteries. Remember, the big line is positive, the short line is negative. This is a switch. This is how it could open up a circuit. It may be a light switch, it may be a push button switch, whatever it is. It's commonly shown like this. This is open with no electricity can go through. And if you see it like this is closed. And sometimes you'll have open circles. Either closed or open, doesn't matter. We're just talking about a switch. And last but not least is a capacitor. Excuse my writing. And it's usually, there's two symbols for a capacitor. Two even lines, looks something like this. But since that can be confused with a battery, you get something like a line, then a letter C. And this is the positive end, this is the negative end. And usually it's in a single direction. And those are the different types of symbols you'll see in this chapter. Now let's talk about some terminology. Load is basically a group of elements that can dissipate energy, do work. We talked about that. So this is the actual definition. An element is a particular component of like a resistor or capacitor that is used to do some work, maybe a motor. An open circuit, it doesn't work. But a closed circuit, you got things going. A short circuit has there's no load. It's just running around. And the only load to actually be more detailed about this is that when you have a short circuit, the load is actually the wire, and it's heating up because you got a lot of electricity going through, a lot of electrons are moving, and guess what? The wire burns up, and it's a shocking experience to observe. EMF, electromotive force. This is potential difference of electrical energy source. And a lot of times when we talk about EMF, we have in the battery itself as a little resistor to help maintain a constant voltage. And this is developed inside the battery itself, and is use voltage, potential difference, and electromotive force. I actually use interchangeably more often than not. Most people say the same thing. For example, when we talk about AC voltages, the potential difference in an alternating current source, we actually look at EMF, which is electromotive force, because the current's going back and forth, alternating between positive and negative, and we're looking at the average electromotive force, not so much a potential difference. I hope that makes sense. So the potential difference across a total load should equal the terminal voltage. So if we have a battery, and it's a 12-volt battery, and we got it going around, and there's a whole bunch of resistors, and it comes back here, and we have a voltmeter going from here to here, and this is a meter, and this is a voltmeter. It will read 12 volts. Same thing as this. So the battery voltage should equal the total voltage across all the resistors and capacitors and so on and so forth. Now, we're not really going to do this, but I'm going to show you what we're going to do with this, because again, I'm going to use this next year in my class. We will draw a circuit with the following components: a battery. All right, there's a battery. And connected with some wires, we have a resistor. And we're going to draw a light bulb. That's how you do it. So this is a 1.5 volt. This is 10 ohms. This is 10 ohms. And this is going to be a 1 ohm light bulb. And we have our circuit. And so we have another one. We're going to have a plug. So here's our plug. And we're going to have a switch. Beep. And connected to that switch is a capacitor. And then we're going to have a bulb. And it's going to come back to the switch, to the plug. Now what happens is that you have the plug, we got this plugged in, and actually another way to do it is kind of like that. Close that, this will charge up the capacitor, and then we'll have this is flowing, and then we open up, the capacitor will still send electricity through the light bulb, and then we have the circuit still open for a while. And in the last circuit, we got a battery. Onto a multi-cell battery, and we've got a switch, capacitor, a resistor, and a bulb. And we'll come back to the end. There we go. So this is how we draw circuits, and we're going to do more of this later, and especially with figuring out resistors and Ohm's law with the resistors.